Welcome, math friends. Here's another online lesson for you. We're going to take a look at using Venn diagrams to calculate probability and the fundamental counting principle. Before we do that, just a quick reminder, I would like to make sure that you understand this work is expected to be shown. I understand that it's tedious and that you do not like showing all that work. But this is something that will be expected if I'm asking you to calculate probability. So let's move on to your notes. This is using Venn diagrams to find probability. And this is at the bottom of page 5 in your notes. We've done some Venn diagrams. Let's take a look together on this one. We have hot dogs, we have hamburgers, and we have sausage. We know that 6 players wanted hot dogs, so we know that hot dogs altogether should be 6. We also know 3 of those that wanted hot dogs also wanted hamburgers. We know this whole section here should be 3. We know that 12 wanted hamburgers, and we know that 15 wanted sausage. Now notice I'm not putting those in the circles because I don't know about the overlap. 1 player wanted all 3. Oh, now I know that. 3 players that wanted sausage also wanted hot dogs. We know that this is 1, and 3 that wanted sausage also wanted hot dogs. That would have to be 2. There were 24 players altogether and all ordered something. So there's nobody out here in the universe that didn't order anything. What's the probability they ordered only sausage? Well, let's see. We do know that this 3 pertains to this overlap in the middle here, so that would have to be 2. Okay, so now I can get rid of that there. We don't know this, and that matters. I can fill in my hot dogs because I have 2 here, 1 here, and it's a total of 6, so 1 would be out here. But I can't fill in this section or this section because I don't know this part right here. So let's think about that. What do we do when we don't know what something is? Let's see. Maybe we can use our friend algebra. So let's let this section be x. If that section is x, then this section out here is 12 minus 3 for the overlap, and then minus x, 9 minus x. The section down here in sausage is going to be 15 minus 3 minus x. So that's 12 minus x. I know there were how many players altogether? 24. So all of these sections have to add up to 24. Why don't you pause here and see if you can solve for x? So here's my solution with my final Venn diagram. Everyone ordered something. So if I take all of these sections together, this section here is going to be 6, and then I had 9 here and 12 here. So that's 27, and then I'm adding x minus 2x. So basically I get x equals 3, and then I can fill in the rest of it. So if this is 3, I really want to know what is the probability a player ordered only sausage. So that's going to be 9, and 9 out of 24 is 3/8. Okay, so it's a little bit of work, but kind of fun. It's a little bit like a puzzle. Next, we're going to take a look at the fundamental counting principle, which many of you know already. If an event can occur in A ways and another event can occur in B ways, the 2 events can occur in A times B ways. Yay! And I know we normally don't use the times. So A times B ways. So at Bob's Diner, there are 6 choices of breakfast platters and 4 different types of juice. How many different breakfasts can you make? Well, it's just going to be 6 times 4. We could do a sample space. We could do a tree diagram, but we could just use the fundamental counting principle. Why don't you go ahead, pause here, and finish this page. So here we have the completion of this page. You can check your answers. I think it's pretty straightforward. If you have any questions, I'd be happy to answer them. Now we're going to skip the page on permutations and combinations and go to page 8, uniform and non-uniform probability models. This is pretty straightforward. It's just vocabulary. A uniform probability model says all of the possible outcomes are equally likely, and non-uniform, the possible outcomes are not equally likely. Chris tosses a coin. If he gets ahead, he wins. Otherwise, Linda wins. Well, Chris's chance of winning is the same as Linda's chance of winning, so that is a uniform probability model. In a game, a die is rolled. If a number less than 5 is rolled, Mary wins. Otherwise, Jake wins. Well, who has a better chance of winning? Mary's chances of winning are 2/3, and Jake is only 1/3, so that is not a uniform probability model, since Jake's chance of winning is not the same as Mary's. If we look at this diagram here on the spinner, it's not uniform since the probability of red is not equal to yellow or blue. And the prize wheel for a carnival game is shown. You receive a less expensive prize if you spin a win on wheel A, more expensive for a win on wheel B. But it's a little harder to win on wheel B because the area there is smaller than lose. Which wheel is uniform? Would be wheel A. And why do you think the winners on wheel A receive less expensive? Because they are more likely to win. So that's it for today. We will get a chance to practice some of this stuff going forward. Have a great day.